Today we're going to talk about unlearning. So the reason, let me just give you an idea of the motivation of unlearning. We might want to unlearn because we learned something we want to forget, right? You can check out my video on forgetting to get some ideas, but maybe it's erroneous, maybe it's a security issue, maybe it's a privacy issue, but there's some stuff in our model that we want to forget. And one technique of doing this is called machine unlearning, which is a really hot field right now in research and also in the solution space. And one of the reasons is we have this memorization problem. If you're just catching up, you can check out my other videos on machine learning memorization. And we have these little bits of information that the models learn, memorize, and that we might want to take out because either it's like somebody's home address or it's somebody's face or it's somebody's voice or it's copyright stuff that we're just spewing out there in the world. And these are all cases why big research places are studying unlearning. Okay, so how do we take away what we accidentally put in there? Okay. Obviously, there's more than one way to solve this problem, but we're going to take a look at unlearning for the next few videos to give you an idea of what's actually happening in this field and how effective is it. So today we're going to talk about defining unlearning. One of the ways we can define unlearning is, hopefully you caught my video on how to forget or studying forgetting. But one thing that we might want to do is we might want to just try to forget. So this can happen by continued training, by training on different data. And basically what we want to do is we want to take maybe a classification that looks like this on the left. And here we want to forget dog, let's say. I mean, it's a silly example, but let's say that's what we want to try to do. Well, we might then further train on different data enough that dog becomes less likely, right? Or we might say completely unlikely. And there's a few ways to do this. You'll learn more in the next video, but this is one way that we can measure and say we have unlearned dog. It's just by comparing the performance or the error on particular examples as we continue training. Another definition that's really happens a lot in the literature is thinking about model distance. So here we have a forget set. We have the data that we want to forget. And we have a model A that has never seen the forget set and model B that's unlearned the forget set. So here we want to say, did I unlearn enough? And we want to somehow project these or compare these in some which way and then measure the model distance. Now, this is great in theory, right? But the problem is that we have invariance in a lot of the ways that we do linear algebra. And so we can have two different transformations in linear algebra that look very different in many projection spaces and yet end up with the same result. And this is the beauty of deep learning. But this also makes this definition incredibly hard to actually reason about in a meaningful way, because we can initialize two models with totally different initialization of their weights and biases, and they can end up learning and memorizing the same task, but look quite different. And so this, I think, is a definition that at least is going to take some work before it's applicable to most of the ways that we train machine learning systems today. Could we define unlearning with privacy attacks? So check out my video on privacy attacks on deep learning models. But essentially in this, we're doing what's called a membership inference attack. And we're trying to run certain data through and guess, is this the model that never saw the example? So the model that literally never had to learn this? Or is this the model that unlearned this? And similar to the ideas around differential privacy, if we can separate these distributions in some meaningful way based on whatever metric we're going to use here, or like one particular way is using what are called scaled logits. So it's the logit layer, which is the layer before the final prediction layer, and this logit layer has, some extra information there that we can use. And then maybe we scale this so that we can better compare, apples and oranges, so to speak. We want to try to put them in some normalized space. And so we use scaling to do that. But basically, we're just trying to say like, oh, I think the threshold, my hypothesis threshold is here. And everything on this side, I think, is the unlearned model. And everything on this side is the model that never saw the example. And if we can do that effectively, then we can prove we haven't really unlearned much. So we want to make these, if we're unlearning correctly, we want to make these distributions as much overlapping as possible. We want to make it almost impossible to tell the difference between a model that never saw the example and a model that unlearned the example. And then there's like what I would call the vibe definitions of unlearning. We just define some tokens that we find problematic, so some word predictions or next pixel predictions or whatever. And then we just try to say we don't predict that way anymore. So this is called approximate unlearning. This is my opinion, the most vibey, because you have to explicitly then define like what do you conceive of as the threshold, at what prediction level of next token with what temperatures and an LLM that you think is enough. And then B, it doesn't actually try to remove that information. It essentially just tries to disassociate some of those connections. This is because of a lot of problems in LLMs that we have around unlearning. I think that the authors used this definition or created this definition as a good enough measurement, and we'll continue investigating, and you can determine for whatever your use case of unlearning whether this definition fits. Maybe it's the best available given the constraints that you also have. So as you can see, there's a whole bunch of definitions of unlearning. Some of them are better, some of them are worse, and there's probably going to be more definitions of unlearning that are coming. And so my take is that we need better definitions of unlearning. Clearly, there's some spicy takes on unlearning in this video, but I think in general, we need more standard definitions so that we can compare results. So if you're actually working in unlearning and you're a practitioner, you want to make sure that you know, hey, I chose the best way to unlearn for the data set I have, for the model size and parameters and architecture that I have, for the use case that I have, and for the type of forgetting that I need to do, the type of unlearning I need to do. So the way that the research is right now is everybody's coming up and saying, here's my new definition. That's fine, but we need to be able to compare those across many definitions. And like you've learned, this is also based on data set size, model size, population, representation, information theory, and complexity. This is not like a simple, I ran it once on CFAR 100, and it's, that represents your learning problem, right? So we really need to have much more standardized definition and testing that's run across many different types of model sizes, of model architectures, and of data set sprawl. Then we need to think about the actual way that people outside of machine learning think about unlearning. So let's say that we remove Monet. Does that mean that Monet disappears? Does removing Monet mean we have to remove all the impressionists, right? We have lots of work, particularly if we're talking about creative work, that is inspired, derivative, stolen, borrowed, all of those things. So if we're talking about unlearning and we're using it as a justification for avoiding copyright protections, then we need to have a broader conversation as a society around what it is we're trying to do with copyright and AI. Just saying. And then what about data that's learned from other examples? So very specific thing. This happened with Facebook many, many years ago, that you could control your face tagging in your own images, but you couldn't control face tagging in other people's images. They changed that, obviously, but it's the same thing. I take a photo of me, I can take it down. Somebody else takes a photo of me, I probably don't even know it's there. So what data and information is extracted about, let's say, particular persons or particular examples from other examples. And this is a problem that we need to address, at least from a practitioner standpoint of do we count this as part of unlearning or not? And then finally, if I remove, let's say, going back to copyright as an example, all of the copyrighted photos of Batman, and I've unlearned all of the copyrighted photos of Batman, this doesn't actually remove the concept of Batman, because there's going to be drawings, costumes, there's going to be a ton of stuff that I don't catch. So what do we actually mean when we say, oh, I unlearned Batman? Gotham wants to know. So I hope this is interesting to you. In the next video, I'm going to dive into how do we actually do unlearning. So what's the latest in research and practice on actually running this unlearning and measuring it as we go. But I'm excited to see you there. Any questions, comments, thoughts, please share in the comments.